Hello everyone, welcome back to the series on Indian mathematics, Ganita Ratna Kosha. In the last few videos, we saw divisibility tests using osculation for divisors ending in 1, 3, 7 and 9. Let us look at how we can handle divisors that do not end with these digits. When we find divisors that do not end with these digits, we break it up into factors which are relatively prime. For example, if I have 63, then 63 is 9 into 7 and I check divisibility for 9 and 7 separately. For 9, I can either use the osculation process, or I also know that we calculate the digital root, and that if the digital root is 0 or 9, then it is divisible by 9. So, we can do that just by looking at the number. And for 7, we can use the osculator. For 7, you can use the osculator, negative osculator. 7 into 3 is 2 and OS bar is 2, and we do the negative osculation process. Similarly, if I have 95, 95 is 19 and 5, they are the relatively prime factors. We all know how to check divisibility for 5, and for 19 we can use the osculation process. So, like this we can break it up into two factors that are relatively prime, and we will be able to use either the common divisibility tests or a combination of the common divisibility tests and the osculation process. Let us look at a few examples. Let us say I was checking divisibility of 34421 by 63. 63 is, as I saw, is 9 into 7. For 9, the digital root, so 3442421. If you remember the digital root, we cancel out 9s. We cancel out all 9s or numbers adding to 9 in the number, that is 4, 4 and 4, 1 add to 9, and 3, 4 and 2 add to 9. So, the digital root is 0, and hence it is divisible by 9. Now, for 7, I have 7 into 3, 21, and my negative osculator is 2. So, I can do the negative osculation process. 3, 4, 4, 4, 2, 1. Let me mark the negatives, and the negative osculator is 2. So, it is 2 times 1 minus 2, it is 0. Then 2 times 0 plus 4, that is 4. 4 times 2 times 4, 4 times 2 minus 4, which is again 4. Then it is 4 times 2 plus 4, which is 12. And then the last step is 2 times 2 minus 1 minus 3, which is 0. And hence this number is divisible by 2. 0 is divisible by 21 or 21, and hence this is divisible by 0 is divisible by 7, and hence this is divisible by 7, and hence this number is divisible by 63. So, this is how we can use the osculation process along with combination of the other divisibility rules we know for smaller numbers to test divisibility of a given number. Let us do one more example. 5985 divided by 95. So, 95 is 19 into 5. We know that the number is divisible by 5 because it ends in 5, and then for 19 the osculator is 2. So, 5, 9, 8, 5, 2 times 5 plus 8, that is 18, 8 times 5 is 8 times 2 plus 1 plus 9, that is 16 plus 10, 26, then 6 times 2 plus 2 plus 5. So, 12 plus 7, that is 19. So, 19 is divisible by 19, and hence it is also divisible by 19, and hence this number is divisible by 95. So, in this manner I should be able to check for divisibility of with any given divisor. I can also do it for slightly bigger divisors. Let us say I have 108. 108 is 27 into 8. These are the relatively prime factors of 108. For 4, we know the divisibility, the last 2 digits. So, this number is divisible by 4. For 27, I multiply 27 into 3. So, that gives me 81, and I do the negative osculator OS bar is 8. So I check 5, 9, 0, 4, 3, 6 with the negative oscillator 8. So let me mark the negative numbers. So it gives me 6 into 8, 48 minus 3, 45. So 5 into 8, 40 minus 4, 36 plus 4, 40. So 0 times 8, minus 4, minus 4, minus 0 is minus 4. That's minus 32 plus 9, it's minus 23. And this is minus 24 plus 2. So the last step is minus 3 into 8, minus of minus 2, minus 5. So that is minus 24, or I can put minus here, minus 24. So that is plus 2 minus 5 is minus 3, that is minus 27. So minus 27 is divisible by 27, and hence this number is divisible by 108. So this is how I should be able to handle 2-digit and maybe some of the 3-digit divisors with a combination of osculation and other divisibility rules for smaller numbers we know. Okay. I have given some problems to try in the notes. Please do try them out, and for any clarifications or suggestions, please don't hesitate to write to me. Thank you.